Hey guys, this is Mrs. Tran-Bloom recording on our 5.5 notes, graphing logarithmic functions. So we will have a parent function here. The parent function will be y equals log base b, whatever b is, of x, okay? Now b has to be greater than 0. It can only be positive numbers, okay? Now x as well, the domain for that is also, you can't have a negative log in there, just like you can't have a negative base. Now the transformation, it's the same as all of the functions you've ever studied. A is still going to be if it's negative, then it's a vertical reflection. If it's in between 0 and 1, then that is going to be a vertical compression. If it's bigger than 1, then that's going to be a vertical stretch. H is still a horizontal shift right or left, and K is still going to be your vertical shift up or down depending on if it's positive or negative, okay? Now, log function, just like your exponential in 5.4, they are very, I would say, related, okay, in a way that there are infinitely many different parent functions based on the base, okay? So based on the base. So I just want to make sure you guys are aware, more than one parent function, okay? And each equation has its own base. So now you have to look at the base to go back and write the parent function. So each equation will be related to the base. So depends on b, aka the base value. So let's start with number 1. Graph the parent function y equals log base 2 of x. Then find all defining characteristics. What I don't want you guys to do is memorize another set of values. So the first thing we are going to do is rewrite this same exact log equation into exponential. So it's going to be 2 to the y equals 2x, okay? Now in this case, your y is your input and your x is going to be your output, because it's 2 to the y. So we will pick values for y, such as -2, -1, 0, 1, and 2. And so remember, in exponential, the input can be whatever it wants to be, right? So now what we're going to do is 2 to the -2 equals, what is x? Well, that's a negative power, so that's really 1 over 2 squared, and so that's going to be a fourth. Yep, exactly. And then same thing with -1. We're going to go, okay, well, y is -1. Remember, we pick the y values this time because y is now the exponent, which is now your input. So we're going to go, okay, 2 to the -1, that's going to be 1/2. 2 to the 0, that's always, okay, guys? Any number raised to the 0 power is always 1. And 2 to the 1 is 2, and 2 to the second power is 4. So I'm going to get a highlighter here and highlight 1/4, 1/2, 1, 2, and 4. Those are the x values when we pick the y value of in between -2 all the way to +2. Now that we have those, let's plot, okay? At a 1/4, we are going to go down to -2. Make your best educated guess where 1/4 is. At 1/2, we're going to go down to -1. And at 1, we are going to stay at 0. At 2, we're going to go up at 1. And 4, 2, 4, I'm going to go up at 2. So would you agree that we did not touch the y-axis at all? Because we didn't touch the y-axis, and we can never get any value that will make x equals to 0. Okay, so that will create an asymptote here. This is a vertical asymptote at x equals to 0. Yes, you must graph your asymptote, okay? So now connect your dot. I notice some of you guys make the dots, but then don't put them together. Don't connect them. So make sure you guys connect your dots. So for log functions, you will have one vertical asymptote here, and then use your, again, I don't need you guys to memorize another set of inputs and output, okay? If you can rewrite it, especially the parent, into a an exponential, then your y value is now your input. Then you can just pick values from -2 to 2 and then just plug it in. All right. H and k, y'all, the parent function, we don't have any transformation, so the h and k will be 0, 0. It looks like it does touch the x-axis at one place, and that's going to be, x-axis is going to be 1, 0. The y-intercept, we do not touch the y-axis ever, so the y-intercept is none for the parent. Okay, you're going to have y-intercept depending on the translation. Then the domain, as you can see, since we can't touch the y-axis, x must be bigger than 0, but we like to write it in interval notation, so that's 0 and all the way to the right, which is infinity. The range is going to be all real numbers, right, y'all? But again, we like to write it as an interval notation from -infinity to infinity. Would you agree that these are sort of switched from your exponential function in 5.4? Yeah, so if you guys go up, you're going to see that those are switched, right? In exponential, the range was actually from 0 to infinity, and the domain was all reals, so that's why. Okay, it is still an increasing function, and it's increasing over the entire domain. That means we don't have any values left for decrease. It is definitely a one-to-one. We have one vertical asymptote at x equals to 0. For log, we don't have a horizontal. A horizontal asymptote belongs in exponential. Okay. All right. Now, as you can see, remember we talked about the log function having a lot, infinitely, many parent functions depending on the base. So here's another parent function with the base of a half. Okay, so again, I talked to you guys about, hey, don't try to memorize points, rewrite it as an exponential function. So 1/2 to the power of y equals x. So y is over here, still the same spot. We don't switch really in the chart, but then because it's an input, so we pick values for y. So anytime you have an input, that's the one that we get to choose, right? Because inputs are dependent. Inputs are independent. My bad. I'm sorry, correcting myself. Inputs are independent. So because it's independent, we get to pick. Now outputs are dependent. So let's plug it in. We have 1/2 to the -2, which, as you guys remember already, is going to be the same thing as 2 to the 2, which is 4. Okay. Then we have 1/2 to the -1, which is the same thing as 2 to the 1, which is 2. And 1/2 to the 0 is always 1. 1/2 to the 1 power is still a half, and it's going to be 1/2 to the second power, which is now 1/4. So all of our, let me get a highlighter to highlight our inputs here and outputs. All right. Okay, so let's plot those dots, guys. It's going to be, whoa, what happened? It's going to be 4, I can't pinch it in, here you go. 4, -2. So 4 to 4, -2. 2, -1. 1, staying at 0. 1/2 up 1, and 1/4 up 2. And again, even if I'm getting very close, right, to x being 0, I still can never get x to equal to 0. Since we cannot get x to be equal to 0, we still have that same exact vertical asymptote at x equals to 0. Make sure you guys connect your dots. If you guys ever miss your dots, okay, just make it really fat. Okay, so, well, compare these two for me. The base 2, it's an increasing function. The base 1/2, it's a decreasing function. Okay, so as you can see, now let's see what else is there different. Okay, the h and k values are still the same. They're 0, 0. X-intercept, we have it at 1, 0. 1, 0. Is that different or the same from the base of 2? It's still the same, right? So y-intercept, we don't have any y-intercept because it doesn't touch the y-axis. Your domain is still from 0 to infinity. The range is still all real numbers, which is from negative infinity to positive infinity. This is the part that's different. It's no longer an increasing. It is decreasing, and it's decreasing over the entire domain. It is still 1 to 1, and we still have the same vertical asymptote at x equals to 0. And no, we don't have any horizontal asymptote. So now if you look at those two, the only difference is if your base is less than 1, okay, then it's a decreasing function. If your base is more than 1, it's an increasing function. Yep, that's true. Go ahead and write that down, okay? Now, the transformations refresher, these are exactly the same as all of the previous functions. If A is negative, vertical reflection. If A is in between 0 and 1, y'all, it's a vertical compression factor of whatever that is, okay? So if it's a 1/4, then it's factor of 1/4. If it's 1/8, then it's factor of 1/8. If A is bigger than 1, such as 1.5, 2, 3.5, then that's a vertical stretch factor of whatever that is, right? So i.e., if I say, okay, it's going to be A equals 5, then it's factor of 5, whatever you want that is. So again, these are just i.e., okay? Again, H is either left or right, depending on it's positive or negative. Same thing with K. That's up or down if it's positive or negative.